a pleasure to be back. Was I the first speaker? Was I the inaugural, or was I the second?
Well, didn't you used to run an R users group yourself?
I did once run an R users group, and it wasn't as successful as this one. So you've obviously got much more pull than I have, which is great, and I'm thrilled to be here. This is not a particularly long, and I hope not a particularly taxing presentation. What I wanted to do is just spend a little bit of time talking about S3 classes as they impact how we interact with R, and maybe how a little bit of knowledge about how S3 classes could make us a bit more efficient in how we solve our problems and debug our code, and then ultimately how we can use S3 classes to help write nice code that's easy to share and easy to use, and importantly easy to generalize. And I've got some examples of from my own work of doing that. So let's pile on in. There's not a lot of structure to this presentation, I have to say. I'm going to start with kind of the motivation that got people thinking about this sort of object-oriented strategy. And the conundrum that the classes are designed to solve is, how do you design a computer language that's easy to extend? Now, if you think about it, when you write a set of functions or a set of procedures for a computer language, it's natural to give them names. You know, when I wrote my first function, it was Andrew's cool function. And I was so happy with that. It just said everything it needed to say. It was Andrew's cool function. And I called that function day in and day out. Then I wrote another function. I called that one Andrew's second cool function. And then third. And I started to bank up against this problem that my function names were becoming longer and actually less revealing. And even though conceptually I could have an infinite number of possible Andrew's cool functions, and I'm sure that one day I'll get there, in the shorter term it seemed to me that there was a problem with my naming strategy. So I started to try to name them after the things that they were doing, you know, like test. So I had my test function, and I had my fit function. And then I shared my functions with other people, and dadgummit, you know, they'd call their functions the same thing. And obviously my functions were the first ones. So I should have had the right to call my functions fit and test and doohickey, and these other people, you know, well, they could just call them something else. All of those functions were all doing different things. You know, I was fitting different kinds of models than they were fitting, and this really gave us this fundamental problem, this struggle of, you know, the power. It's almost like, you know, when Adam was asked to name all the animals. You know, we're being asked to name all of our functions. We don't get to do them all at once. So the language, you know, imagine if we ran out of names, the language would stop growing. So how do we solve that problem? I want to fit, you want to fit, I want to predict, you want to predict. Let's call the whole thing off. No, we can't do that. So the struggle then is, how do you develop a sufficiently flexible naming system that allows for expansion without forcing the user to memorize 1 billion different function names? Andrew's cool function 1, 2, and 3, and so on and so forth. Well, that's the problem that S3 classes is designed to solve. Really, there are other problems that it solves as well, but those problems aren't what it's about, because it solves those other problems quite poorly. Really, the problem that it's designed to solve is, how do you handle this function naming conundrum? Just to give you an example of the kind of expansion, I ran this little command here. I'll tell you what it does. It says apropos, which means find all the stuff that looks like. And then in quotes, I've got a little string there, and it's caret print. And the caret is a regexp wildcard that says make this the beginning of the word. So I've asked it to find all of the things, all of the objects in the search path that go print and then have a dot. Okay? And then I asked it to return those. So it found a bunch of them. And then I said, okay, now give me the length of that bunch. And it said 47. So there are 47 print dot somethings in there, which tells me that there are 47 different ways of printing things in R. Imagine if you had to know how to print each of 47 different types of objects. Like print my LM, and print my mean, and print my other stuff, and print this, and print that. It would suck. So we don't have to do that. S3 classes to the rescue. Before I get too involved in how S3 classes solve this problem, I want to talk a little bit about object-oriented programming. Now, this is made, my goal of talking a little bit about object-oriented programming is vastly simplified by the fact that I only know a little bit about object-oriented programming. That's the first thing. And secondly, there really isn't a single kind of object-oriented programming, or OOP. There are lots of different species of OOP. So I can tell you about this one, content in the knowledge that if you say, but what about procedural? I can say, well, that's a different kind. My friend, it's beyond the scope of this presentation, but thank you for bringing it up. So what characteristics of object-oriented programming am I going to rely on in this presentation? Encapsulation means that there should be some things that are hidden from the user. And really what the goal of that is to not overwhelm the user with all kinds of different details. Great example is this idea of naming something. Instead of naming something my function what prints out LM, I just want to be able to write one nice little function name that's specialized in some way for the LM output. So encapsulation means that the user isn't overwhelmed by the details of the language, that they essentially can take a higher level kind of look at things. That's a very useful facility. It's nice to have encapsulation because it means that the entry into the language is easy. The second thing is inheritance. And inheritance means that we can share code amongst different types of objects very easily. Well, and I'll get onto what I mean by that in more detail later on. But essentially what it means is, let's say if I had the classic example is if I had a linear model and I wanted to do something that was related to the generalized linear model, I wouldn't want to have to rewrite my whole function to specialize for the generalized linear model. I'd like to write this all in such a way that my function could cope with the linear or the generalized linear model, and I'd like to say that a number of the things would be in common and some things would be different. So if I'm writing a set of functions for linear models, I'd like to be able to rely on my generalized linear models functions or vice versa without having to specially write different code for each one, especially considering how common they are. Okay. Polymorphism means that individual procedures should be able to accept or return more than one type of object. Specifically, polymorphism in the case of S3 classes means that I should be able to call a function and it should accept different types of input, different classes. I'll define that in greater detail later. Different classes of input, and it should be able to spit out different classes of output. Polymorphism means I shouldn't have to declare what those things are from the get-go. I should be able to have flexibility. Now, of course, there are good reasons to not allow polymorphism. Okay, every design choice involves a compromise. And what S3 classes are designed to do is they're designed to solve a very specific type of problem. But there are other design solutions that are intended to solve other kinds of problems that are also totally legitimate. So polymorphism is good for S3 classes, but it's not everyone's cup of tea. Okay, so let's talk about S3 object orientation. I'm here to tell you, S3 object orientation is like the Clayton's object orientation. It's the object orientation that you have when you don't have object orientation. It is super light. It is super deft. It is super simple. There's a very little bit of infrastructure to learn in order to be able to use S3 classes. Okay, it's just like the little nephew or little niece of object-oriented programming. We need some vocabulary. It's class-based as opposed to procedure-based or function-based, and it's what's referred to as an impure or hybrid object orientation, simply in as much as you don't have to use object orientation to use R or S. Okay, you can get away without using it at all, although you'll be more effective if you do use it. So it's like C++ in that way. It is possible to program C++ in a way that totally ignores classes, and in fact, just be bloody minded, I've done that. But that doesn't mean it's actually a sensible thing to do. So a class now is going to be an attribute of an object that dictates what messages the object can receive and what messages it can return. A method is a function that will be designed for a specific class. And I'll use that word quite liberally. And dispatch is selection of a method to apply to a particular object because it's of a particular class. I know that's all very abstract. It'll get much more concrete very shortly. So S3 object orientation uses classes and methods. So what does that mean in terms of the language? Let's get concrete now. This is, I'm sure you're familiar with the idea that if I type the name of something into the interpreter and hit enter, then it prints the something. It just pops it out. So let's see what the mean function is. I type in mean and hit return, and it gives me a function. It gives me the arguments of the function, x and the ellipses. And the function is use method mean. And then it gives me some byte compiled stuff, and it tells me where the environment, what the environment is and so on. But here's the key stuff. It actually says all that mean is just use method mean. Now that's just mysterious. Just mysterious. It's as though it's like a hand pass. The mean's got the ball, and it's hand passing to something else called mean by use method. But who's it hand passing to? We don't know. We'll find out shortly. So mean is an example of a generic method. And that means it's a method that in itself doesn't actually do anything, but it hand passes to whichever function is going to be invoked. The way it chooses which function to invoke is it looks at the class of mostly the first argument. It's actually not always the first argument. You can use a different argument than the first argument. Mostly it's the first argument. So when I'm calling mean, this generic function, it's going to look at the class of x. It's going to look at the class of x, and then it's going to hand pass to the function that is called mean dot and then the class of x. So if x is a data frame, then it's going to hand pass to mean dot data frame. That's dispatch. So it dispatches to the appropriate version of the function. That's also polymorphism, because the mean function, therefore, can take a number of different classes of objects, and it just throws throws to whichever function has the appropriate name. So what kind of functions do we have to throw to? If we do the apropos trick again, then we see that there are 6 different methods, including a default method, that apply to this generic method, the mean. Okay? If I've got something that is class date, then this function gets invoked. If I've got something that's diff time, then that function gets invoked. If I've got something that's pretty much any other kind of class, then this function gets invoked, mean.default. So if we want to find out what's happening to our data when we call mean on it, the obvious step is to look at the mean function. That doesn't fly. We've got to look at the mean.default function. Let's do that. And it's this long thing here. It's all of this stuff. This is all preparation. Here's the call that counts. Dot internal mean x. This calls compiled C code. And if you want to know what that's doing, you've got to go back to the source, which is not the subject of today's presentation, so I'm not going to do it. But this is all wind up, and here's the pitch right there in dot internal, and it calls mean. So this is all running on compiled code as of now. Okay, so let's recap. We're thinking about generic methods, and the mean is an example of a generic method. And what it does is it looks at the class of the first argument, and then it says, I'm going to find a match for that class. And the way it determines the match is it just prepends the name of the class from its own name with a dot in the middle and looks for a function that's called that. And if you can't find one, it goes for default. It calls this, which goes into the C code. Feel free to interject at any time to ask me questions. If I don't like the question, I'll ignore it, okay? Okay, so how do we find out? What's a convenient way of finding out what methods are available for a particular generic function? We'll use the methods function. So if we want to know, if we've got a function and it's generic, and we want to know what types of objects, what classes of objects we can call it on, well, we simply need to call the methods function. And it tells us, just as we learned before, there are 6 of them. What about the methods that are suitable for a particular class? These are all the methods for a generic. The methods for a class we get by supplying the class argument. This is all of the methods that are available for an object that is of class NLS, which is nonlinear least squares. I had to find a balance, right? Because mean didn't have very many. And if I'd chosen something like LM, it would have gone off the page. So I had to experiment a little bit just to find a class that had just the right number of this is like the Goldilocks class. You got a question? Sorry.
The non-visible functions are asterisks.
Yes.
What does that mean? What's non-visible?
That is a great question that I was just about to answer. In fact, it's a perfect segue into where I'm headed. Thank you. This says that non-visible functions are asterisks. And as we can see, all of them have asterisks next to them, which implies that all of them are non-visible. What that means is that the package that supplies all of these functions has not made them visible in the namespace. And I'm going to talk a bit more about that in a moment. So this is the other way that we're getting a little bit of encapsulation, is that R now uses namespaces, and objects are either exported from the namespace and therefore available, or not exported and therefore not in the search path. And all of these have not been exported and therefore are not available in the search path. Now, it doesn't mean you can't look at them. It just means that you can't mess with them unless you really want to. So, how do you mess with them? That's a good question. I'm glad you asked. Let's say knobs. Seems like a friendly little function. Knobs, which actually is the number of observations. It's not an insult. If we type knobs, which is a generic, it's a function. The first argument is called object, and then there are a bunch of other arguments. And its use method, knobs, as before. So let's see how many different types of knobs there are. Do I find that out? No, I don't. What I want to know is, I should have, but I didn't. What I want to know is what's knobs.nls. If I type in knobs.nls, it says error object not found. Now that means that it's not in the search path. It's not in our search path because it hasn't been exported from the namespace. And that means it's not visible. Okay, what's our solution? Our solution is get anywhere. The get anywhere function says, we don't need no stinking search path. I'll find you wherever you are. And so if I run get anywhere on knobs.nls, then it hunts around until it can find it. It finds it in the stats namespace, and here's the function. If is null w assignment objective $weights, which, I mean, that's an assignment inside a function call. That's very naughty. Length, object, blah this and stuff and everything else. Good. That's the function. Obviously the details aren't really important to us. But that's how you get it, with get anywhere. Now there's another way to access it. Once you know what namespace it was hidden in. It was hidden in the namespace stats, and we can also get it directly by use of this peculiar triple colon. If you use a triple colon between the namespace name and the function name, why then you pull it right out. So that's a convenient sort of short way of getting at it if you don't want to use get anywhere. But the nice thing about get anywhere is that you don't have to know what the namespace is. You can it'll just find it wherever it is. So that's convenient.
If you did $sign and obs.nls, will it come up in the listing?
$sign.
So if you do a search.
You mean double query? Or
sorry, double question mark.
double question mark, yeah. I don't know. I've never tried. That's your homework assignment.
Okay.
I just gave a lecture earlier today. You can tell, right? Any question I get, that's a great homework assignment. Do you have a question? Do you have a homework assignment?
No.
Oh, you sure?
What if you didn't have like the library or something like that?
Then it wouldn't be available. Get anywhere doesn't really mean anywhere. It means where. Yeah. No, that's a good question. You've got to have that. The package got to be loaded. Well, we don't call them libraries. They're packages.
How can we find the namespace of the invisible functions?
Say anything, right?
How can we find the namespace of the invisible function? Use the get
anywhere
functions?
Yeah, get anywhere will tell you the namespace. And you might, it also will appear in help.
Mm-hmm.
So there are lots of functions for which help is available, but that aren't visible themselves.
Yes.
And the help function will tell you the namespace.
Okay.
But get anywhere is, it's generic and it's friendly and fast working and eager and enthusiastic. So how do you make a class? That's a good question. That's the thing we're going to handle next. So here's an object, x. It's just numbers 1 to 3. And I'm going to invoke a new class simply by this means. I'm a class of x assigned digits. That's it. Digits now exist as a class, and x is an object of class digits. That's it. That's S3 classes right there. There's no centralization. There's no register. There's no prototypes. There's no creating and destroying objects. There's none of that. There's just take a class name and assign it to the class, and that's it. You're done. It exists, which is just crazy. I mean, it's so simple. It does have its fallbacks, and I'll talk about those in a little while. I mean, shortcomings, I should say. Now, if we want to check, I type the attributes function, attributes of x, and it tells me that one of the attributes of x, in fact, the only attribute of x that is worth note, is class, and it's class digits. One thing I do want to draw your attention to is this assignment. I was just reading Chambers' book, and he draws our attention to the fact this is actually quite an extraordinary construct. This is really unbelievable. Ordinarily, you save the output of a function call as something else. Here, what we're doing is we're saving something as the output of a function call. That's crazy. I mean, that's just wacky. It's totally backwards. We're saying class of x, and we're assigning something to it. So ordinarily, you'd assume that class of x would return something. But when you assign something to it, it says, hey, I know what you mean. You want me to make an attribute on x. So you want me to return a new version of x. But it doesn't say return x there anyway. It just says mess with the class. So this is actually quite an extraordinary and non-intuitive aspect of R, is that the function calls can be assigned to as well as from.
What happens if the next thing you do is type class of x?
It says digits,
Right.
as you'd hope.
Yeah.
So it even knows what the context is under which that function is being called. The same function is being used to set and to get the class. Now that's wacky.
Can you
And
assign
great.
to any function call? Or
No,
Okay.
no, you can't, because this is also all about classes. There's classes under the hood here as well, and if you try to do that, you'd make a mess. Don't do it. Okay. What about if you want to write a new generic function? There aren't that many generic functions. There's maybe about 20 or something. What if you wanted to write a new one, which I'll do in a little while? Then all you do is you choose the name for your generic function, and you call it function of x, for example, and then you give it the 3 dots in case you want to, in case any of your methods you want to pass on some extra arguments, and use method reveal. That's it. That's the generic right there. You write that, you have a generic function. It's great. So easy. I have to say, S3 classes do make object-oriented programming entry level. Dead simple. And that they're fabulous for that. Absolutely fabulous. What about if you want to write a method that could then subsequently be called? Well, I'm going to write a default method. That's just reveal.default. Is a function, let's just say I want to use the head function. Who cares? It doesn't really matter. And here's a reveal function for the digits. I'm going to do something a little bit weird here. My function is I want you to paste all the elements of x and collapse them and use commas to separate them. That's my reveal function. So now if I type reveal of x, I get this output. That's my S3 classes right there, the whole thing. Hi.
Do they have the same signature as the generic function?
They do not.
Okay.
But if you try to submit something to CRAN that doesn't, then they'll slap your wrist. Because our command check checks for those things, but they don't have to. And in fact, oh, wait a minute. I think they just have to be compatible in a way that when you call reveal, then the arguments will be comprehensible to both functions. Because otherwise, so they've got to be compatible, but they don't have to be identical. So I can have a string more of arguments in this one. And then when I'm calling reveal, if I provide those arguments, that's nice. But because of the ellipses, it won't be bothered by them. Okay, so this is it. That's the whole business. What reveal does is reveal is a generic method now because I wrote it as a generic method. And it looks at the class of x and says, hey, x is digits. And then it says, okay, I need the digits version of myself, so it invokes this function here on x, and that's the result. So this is an example of that encapsulation idea. I don't have to write a reveal my digits function. I just have to write a reveal function that responds appropriately to things that are of class digits. So the user now knows whenever they're tooling through my code that if they type reveal, then it's going to, assuming that their object is of class digits, it's going to do the right thing. Now this is extremely useful for entry level into the language, because users don't need to know billions of different names of functions. They just need to know print and mean and summary and reveal. Simple things. Great stuff. What about inheritance? Well, here's a very simple example of inheritance. The idea behind inheritance is that I'd like my objects to be able to borrow code from more general classes. I'd like to be able to think that, let's say my, this is a good example here, let's say my x was those numbers 1 to 3. I'd like not only to think of them as digits, but also as numbers. So if I asked for the mean of those things, I wouldn't want it to go looking for mean.digits, and then if it couldn't find it, then to have kittens. I'd want it to go looking for mean.digits. Oh, I can't find that. Well, mean.numeric. Now, this is a very artificial example, very, very, very artificial example, in as much as R is smart enough to do that anyway. But this is how you would set it up if in the contrapositive that R was dumb. You'd say the class of my object X is now digits and numeric. So I was going to say, when I call a generic, I was going to say, how do I handle that with digits? Oh, I don't know. Let's try the numeric instead.
What would happen if you do have a mean.digits and a mean.numeric?
It would go to mean.digits first.
Because you wrote digits first and that.
Yes, that's right. Okay? So that's how we create inheritance in S3 classes. We just add to the list. In theory, it's only supposed to inherit from more general classes. And if you do something else, then you really run the risk of making a mess. But in practice, you can make it inherit from anything. The responsibility is, of course, on your shoulders. So what else can we do with knowing S3 classes? Well, one thing we can do is we can override methods. So here's an example of fitting a generalized linear model with some data that I'm particularly fond of, the Upper Flat Creek tree data. What I've done is I've noted that a number of the trees have been measured for their diameter and for their height, and a number of trees only for diameter. So I'm curious to know, is there any pattern in the choice of which trees to measure for height? You know, maybe the fat ones were being skipped, or maybe the foresters thought the fat ones are valuable, and therefore they might focus on the fat ones when they're measuring height. So we could answer that question by fitting a model. We could say, for some of the trees, the height's missing. For other trees, the height's not missing. Well, that'll be our response variable. And then we'll see whether that's a function of dBH or not. And we'll use the binomial family with the default logit link. And if I ask for the standard confidence interval from that model, then it does profiling, which is known to be high quality, provide high quality estimates. And it provides these intervals. But let's say I wanted to just compare those with the Wald estimates, which is the estimate plus or minus 2 times the standard error of the estimate. Well, I can't get that from Confint because Confint itself actually uses this profiling when it's called on a GLM object. But what I could do is I could use the default Confint function, which it turns out is smart enough to take the GLM object and calculate the Wald intervals. Now, this is an interesting example of flexible programming. The GLM object wasn't designed to be used this way. It wasn't intended to be used that way, but the naming of the object and its components was sufficiently generic that if you force config.default to work on it, then it gets the answer right anyway. So there's an important clue in there about writing code for general use. It's not only setting up a class structure, but also thinking about the names and the classes of the objects that your functions return and that they expect. So clearly, I add in passing config.default is really designed for the linear model. Clearly, GLM has been written in such a way that it returns things that have the same names and the same interpretations as the linear model. And that's useful, because that means that if I want to get the walled intervals out of it, all I have to do is call config.default. This is an abuse of the language, but if it's what I need to do, then I'm going to do it. So let's fold back on our earlier definitions. The point about object orientation, the broad, abstract, conceptual point, is to think about objects passing messages to and from each other. And the characteristics that we're looking for are encapsulation. We saw an example of encapsulation when we saw all of those non-visible functions that were hidden by not being exported from the namespace. We could get to them if we wanted to, but the user wasn't going to be confused by all that detail. Inheritance, we just added to the vector of class labels. We started off with digits and then we added numeric. Now that was a dumb example, all right? Full disclosure, don't need to do that. R smart enough to know that it can take the mean of those numbers anyway, but that's how you would do it in the general sense. And polymorphism, an example of polymorphism is the method dispatch, where R looks at the class of the function, of the class of the significant argument, which is mostly the first argument, and it just says, I'm going to call the version of the function that handles this. And that's a great example of polymorphism. So we've got all these object-oriented values coming from S3 classes and augmented by namespaces. Now, how can we use this information to help us be a little bit more effective when we're doing programming? I've helped a number of people solve R problems, and my guesstimate is that about half the problems that I solve using the str function. That's it. That solves all of the half of the problems that I solve using the str function are solved using the str function. The first question I ask is, what is the class of the object that is in my focus? The second thing is, what is the dimension? Usually, often the dimension is not what is expected. What are the components and what are the classes of the components? The str function really helps you solve a lot of problems, because the way R works is it assumes it's got S3 classes baked into its operations. It's going to use S3 classes all the way through, except for some specialized extensions that use S4 classes. So consequently, knowing the class of the objects, knowing the dimensions of the objects are absolutely essential to be sure that R is doing the right thing. Here's a classic example of where that can go wrong. Let's say you've imported an Excel spreadsheet. You've imported the Excel spreadsheet and R has made some assumptions about the class of the columns. R, for example, might have assumed that a column was a factor when you meant it to be character, or the other way around. Or perhaps you've got, unintentionally got some text in the column, and R has interpreted the column as characters instead of as numeric, for example. This can happen. It happens a lot of the time, especially in that critical data import time. So then you write some code and it crashes and you don't know why. The first thing you should do is look at the structure of the object that you're calling the functions on. And that'll tell you if everything is what you expect it to be. Okay, and it's the class that makes the difference. There are lots of times, R can be very forgiving. There are lots of times when R can look at something and say, you know what, I know what you really mean, and then just convert it for you. It can coerce an object into another class. But sometimes that won't work. And when it doesn't work, it'll just throw an error, and often the error is completely incomprehensible. So go for the str function. It will solve your problems. Okay. So what are the drawbacks with S3 classes? Seem to solve the problem that I started the presentation with quite elegantly, and that is we don't want to have a plethora of names. Well, we're not going to have a plethora of names, but eventually we're going to run out of class names and method names and so on and so forth. So the way that also there's no central control, and that means that we can do things that are bad, programming wise. We don't have, and we can create objects, for example, that are illegitimate. We can call it a numeric, but actually it's a letter. And R will just have a little cow about that, and reasonably so, because it doesn't know what to do. Consequently, S4 classes have been created and introduced over the past 4 or 5 years or so. These are designed to be much more centralized, much more secure, and much more controlling. As a consequence, they're tougher to use. And the learning curve is higher, and they're not as convenient, and they're trickier. And that's why I'm not talking about them today or at all. I haven't, in my use of R, found a need to move to S4 classes. There are people who have, and that's awesome. They're great programmers, and I'm not one of them. So, S4 classes have been created to solve the problem of no central control and of being able to make objects that you say are one class but actually look like another class and all these kinds of things. But I haven't needed them yet. I'm not very experienced. And namespaces are also used to solve the problem of encapsulation. They're actually a relatively recent introduction. So, what else can we do with S3 classes if we're just messing around with them? I mean, in addition to creating functions, how could you actually use S3 classes in a way that might be interesting on a day-to-day basis? Well, one of the ways I've been using them is using method dispatch to simplify, although it does slow it down a little bit, to simplify flow control. Let's say I have two functions that I want to call. These are obviously very simple functions, increment A and increment B. And let's say I'm going to call them on an object depending on the value of something else. So essentially I'm saying I've got a flag, and I'm going to call increment A or increment B on an object depending on the value of the flag. And the traditional classic way of invoking this would be to use if flag equals something, then increment A, else increment B. Okay, and that's the canonical way to solve this problem. And that's what that might look like. So here's my use if function. If the flag equals A, then call increment A, else call increment B, and there I am running the function use if 10, and it returns 12 because the default value was B. So that meant add 2. All right, that's pretty straightforward. Is everyone comfy with that function? Just the broad structure? Okay, that's great. That works perfectly well. It's pretty quick and everything. What about if I wanted to use method dispatch? And I'll explain why I might want to do that in a moment. If I want to use method dispatch, then I first of all have to create my generic function. There it is. That's my generic method. And notice that, just going back, notice that these two methods are now, they've been written in an S3 friendly way. If I'm willing to use A or B as my class names. I should warn you that what I'm showing you is also kind of an abuse of the language. I showed this to a good friend who's an absolute expert R programmer, and he raised his eyebrows and he said that he didn't think that John Chambers would approve. But it's a matter of personal taste, in my opinion. So this is how you'd use dispatch to do the flow control. First of all, you take the argument x and you assign the flag to its class, and then just call increment. And instead of the if then else construct handling the control, method dispatch handles the control. And if I run this use dispatch 10, I get the number 12, and it's got certain attributes as well, which is a consequence of what I've done. Now, what I like about this approach is, in this particular case, it's pretty trivial. But if I had 10 options, or 4 options, I'd be doing if, else, then, blah, 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 blah. I'd have this complicated cluster of if, else's that I'd then have to augment if I wanted to change. That's kind of inflexible, and it's kind of messy. Using the flow control, using the method dispatch means I just have one call. And if I want to add another option, say for the flag value C, well, I just have to run another one of these. Increment.c, and then return the flag C, and I will pick it up. I don't have to put in more if-else stuff. Pete?
Given this S3 stuff uses the period to figure out the class,
yes.
Do you tend to avoid using periods in variable names and other?
I wish I could, but they're so convenient.
Yeah. So
the answer is no. I don't tend to.
And do you run into problems because of that, or is it?
I haven't so far. But I could. It's a bit slower to do method dispatch to do flow control by method dispatch, and you may or may not care about that. I do think it's cleaner. But that's just a programming choice. It's kind of an abuse because, do I have this slide next? No. Okay. There's one other thing it's also an abuse of the language, but I'm going to talk about it anyway. I remember I talked about the idea of inheritance as being sort of this generalization. So if I had a GLM, then I could put an LM after it, and it would mean my GLM function, my GLM object would pick up the LM functions if there weren't a GLM function that was suitable. You can also use inheritance for that, for a kind of multiple dispatch kind of approach. The 3/4 of the book that I'm working on right now that Jeremy mentioned is essentially a method, a statistical model estimation methods in R kind of a book. It's nearly done. What my co-author Joe Hilb and I do is we write a GLM function using S3 classes, and we use this sort of inheritance dispatch method to control the family of the response variable and to select a link function. And this is in no way hierarchical. These are like orthogonal, I mean, in many ways. So consequently, this is completely an abuse of the language. But again, it seems to work. Because all S3 classes are doing, they're not doing anything fancy. All they're doing is the things I've described. So that's exceptionally general. It's not designed to be used in the ways that I've just been using it, the method dispatch and figuring out how to communicate a family and a link. But actually, you can do it anyway. And it makes for code that I think is quite nice and easy to read.
Could you maybe give an example of how this solves a problem?
I can't give you the full example because the code's like that long, but I will give a sort of very high-level example. Yes. And for the full example, you can buy my book when it's done. Oh my, it's nearly done. I'm the laggard, right? Joe's done. Joe's finished all his stuff, and I'm dragging. So the distinction I want to draw to here is a sort of method-centric versus object-centric programming style. The traditional use of S3 classes is that we should have objects that we care about and that we nurture, and that we should write methods that are specific for those objects. But actually, I'm a statistician. I write methods. I don't write objects. Objects are just data, separate bits of data that come to me. I write methods, and consequently, I take a much more method-centric approach, which means that I focus on writing methods for different objects rather than writing a collection of methods for one object. So this is a method-focused example. I'm writing a whole bunch of generics for the joint log likelihood of a function, for the link function, for the first derivative of the link function, for the unlinked function, and for the variance of the family. So these are just generic functions. And if I want to write a logistic regression function, I'm going to write specific versions of the joint log likelihood and the variance that correspond to the binomial distribution. And I'm going to write specific versions of the link functions that correspond to the logit. And I've written, and I'm not showing you here because it's that long, I've written this other function that you can call that fits, that does this sort of fitting. By calling it calls variance in the function, and it calls the binomial variance if the object has class binomial. It calls the link function, and it calls specifically the logit link function if the object has class logit. So I'm using this sort of multiple dispatch, this sort of two-dimensional dispatch to control both the family and the link function that's being invoked. And then, having written all that infrastructure, if I want to use a new link function, I just have to write the functions, the link, the first derivative of the link, and the unlinked function for a different link function, different link type, and then I can call those as well. And the same thing applies with the different family. If I want to write a Poisson family, I just need to provide the variance of the Poisson, which is the mean, of course, and I need to provide the log likelihood. And then I can invoke the same single function can then use iterative proportional, iteratively reweightedly squares to fit a totally different family of models.
Okay, so I think I understand what you're doing with your previous example now. When you had that class of
Yeah.
X was GLM family link,
Yeah.
you're actually specifying the specific family for that GLM. So you're calling it GLM, appropriate, and
Got it.
binomial, and so
You've
on.
got it.
Okay, that
Yeah.
makes more sense.
Yes, yes, that's right. That's right. You don't have to do any homework.
So it feels like you're sort of attaching multiple attributes, all squishing it together into just the class attribute.
That's what I'm doing. Isn't that naughty? Yeah, that was the thing that really made the eyebrows go up. It's like, wow, these, I mean, because they're supposed to be a hierarchy of generalizations, and this is not. I mean, this is nowhere near it. This is just using method dispatch to send signals. It's sending messages, I figure. It's a message. An example of an object focus use, and this is a very trivial one because I was thrashing my brains and I realized, you know what, I'm a statistician, I don't have a better example than this. I like playing games, computer games. And one of my favorite sources of information about computer games is Metacritic. And what this does is it gathers together reviews of all kinds of media, so movies and books and TV programs and computer games. And then it averages, it summarizes them, and it sort of does a very loose kind of meta-analysis. And I decided that it would be an interesting exercise to scrape the whole site using R. So I wrote some code that would download. They very foolishly put a list of all of the games on a single page. So I grabbed that page into R, and then I used grep to grab all of the addresses. And then I downloaded one by one all of the information from each game. The URLs were constructed using string manipulation and the components of the page that I'd stolen. So I was able to grab these 37-odd thousand reviews of all these games. And I started to do a little bit of analysis on them, and then I decided, well, it might be fun to use this as an example of an object focus. So I was thinking, I mean, tragically though, I was thinking about all the things that would be cool to do with this, and really none of them require generics or methods or anything. So that would have been completely artificial. So rather than be completely artificial and take a long time about something, I decided to be completely artificial and take a short time about something. So I'm going to add meta to its list of to its list of classes. I'm going to write a print method. So print.meta is a function of x and n, and it's just a paste thing that takes the nth row and tells you something about it in a way that's easy to read for a human. And so here's the outcome. I'm printing games, row 15, and it tells me that the meta score from the Eurogamer source of the game, which is 1503 AD New World, which I've never played, and about which I make no endorsement, is 74. Okay, again, you don't have to remember anything other than you're the user, you just need to know print. That's all, that's it. Okay, so now, key points to the presentation. First thing is, we talked about S3 classes and object-oriented programming and how S3 classes delivers some of the aspects of object-oriented programming. And what those aspects were, the encapsulation, the polymorphism, and inheritance. Also, we talked about how mind-blowingly simple S3 classes are to use. Really, they're wonderfully simple to use. They're fabulous for that. You just write a generic called foo, and then for anything that has class bar, you just write foo.bar and write that function. You call foo, method dispatch picks the foo.bar function, and that's it. Very simple, very straightforward. If you want to know more about any individual generic, you should use the methods function. If you want to find a function that is hidden, use the getAnywhere function. This will help you a lot of the time when you're using R, because often you'll throw errors in functions that can't be seen. Use getAnywhere to find them. And str, the structure command, is fabulous for debugging. Most of the problems that I have solved for other people have involved identifying the class and the dimension and figuring out that they produced something other than what the code expected. That's it. That's S3 classes in a nutshell.
Do you have any questions? Is there such a thing as S2 classes?
Nope. S3 classes are named for the version of S for which they were released. S2 had no class. It was,
Do S3 and S4 classes clash?
they are not missable. So they can coexist in an R session. You can have S3 classes being manipulated, the objects of S3 class being manipulated by S4 functions, but it's generally not held to be a good idea to mix them. Pick a paradigm and stick with it.
It's a good idea to write your, say, print dot
Bar.
diff or something like that that already exists, in the language if you don't like the way the things put out.
Yes, absolutely. Yeah. And for many special cases, when you're dealing with clients, for example, they may want to have the output done in a very specific way, and it's convenient to write a new function that will do that. Absolutely.
If you have a non-visible function and you define a new one with the same name, what happens?
Well, it depends on where you put it in the search path. It doesn't overwrite it, but it should be called in preference of it, I believe. I haven't tested that in a long time. I don't remember what the outcome of that test was. That's a homework problem.
Got a lot of homework today.
I think
It's a good day.
for that question, if you have a non-visible function, it can only be called by another function in the same namespace in which it exists anyway.
Right.
So if you define your own function, that function and the other namespace won't see your function. You can call your own function,
But another function can't.
That's right.
Yeah, because the other function will be looking for it in the namespace, not in the top of the search path. That's probably right. Yeah.
This is a follow-up on the question I asked just before. So it seems to me in statistics that a lot of the print functions for the various tests give output that's absolutely terrible. It's not well formatted, it leaves out stuff and all that sort of thing. Do you agree? And if so, why is that?
There's some that I don't like, but I've been using it so long it's just emblazoned itself on my brain. Certainly I don't publish any of it. I make tables. And the reason would be it's just the default output. I don't think there's any particular reason for it per se. It's just what seemed like a good idea at the time. And you can certainly write a new print function for anything that you want. For example, Andrew Gelman wrote a function that I think is might be called display, and it essentially will produce a model summary, but in a format that he finds much more pleasant for himself and more informative.
Any suggestions for other sources for learning more about S3 and the like?
The blue book, no, the white book, the white book, which is Chambers edited 1987 or thereabouts. That introduces the classes in the appendix. Avoid the green book because it doesn't really mention S3 classes at all. I don't remember about the blue book, but it might. Other sources? Yes, there's actually a book called Introduction to Scientific Programming and Simulation Using R, written by Jones et al. Talks about S3 classes and S4 classes and gives some lovely examples. Available cheaply on Amazon, and I'll sign a copy if you want.
That's the book I'm working through.
A quick plug from, is it any good?
It is actually.
Oh, that's good, thank you. Took a risk then. So yes, that's very well reviewed. I'm surprised you don't already own a copy, Peter.
Can I have this question? So I'm just wondering, do you write just regular functions called blah blah or something? Do you have functions that are not S3 classes?
Never used blah blah as a function.
Because I know
I do, yeah.
most of the time, I think, well, this feels so niche or so specific. It's not I'm not writing a package that for general consumption. It's just a function that I want to run on one variable. And maybe also, what's your threshold for saying, oh, I think there's this either mental or naming benefit of moving to S3 classes versus just having one function after another with its own unique name?
Good question. My threshold would be if it seems fun. Really? There's honestly, in my work, there hasn't been a problem that's been complicated enough to demand S3 classes. But there have been problems that have been vastly simplified by using S3 classes. And that's the way I tend to look at it, is that if it looks like it's going to make life easier for other people as well as for me, then I'll deploy them. Otherwise, I won't. And usually I write code for myself, so usually I don't use them. So for data analysis, for standard data analysis, no, don't need them.
It's more of a making life easier for other people argument. Yeah. So running simulations or constructing complicated models. Or, an example I was working on recently, I was simulating the process of doing the continuous sampling plan, CSP1, on historical inspections of quarantine items. And I wanted to write something that would essentially loop through the history, but I wanted it to be sufficiently generic that if I didn't like CSP1, then I could write it for CSP2 or CSP3 or CSPN. And I used S3 classes to provide dispatch rather than if this equals that, which is the example I showed. And so I wrote this function that's this long or thereabouts. If I want to change the algorithm, I just need to write new methods for it. So it's like 3 more functions and it'll fit something totally different. And I like that a lot. That gives great flexibility. So yeah, it's only for pretty complicated problems relative to my experience that S3 classes really shine. Except I use them all the time in debugging because they tell us what version of the function. You've got to know the class of the object to know what version of the function R is calling. And then you've got to find that version of the function to see exactly what R is doing in order to be able to understand where the code is crashing. So I use I use my knowledge of S3 classes a lot for debugging, daily, because my code is crap. It always crashes. So I have to use S3 classes a lot to fix those problems. Thank you.
You're welcome.
So I should say that if anyone wishes to hang around, you can probably go out for a bite to eat.
I'm afraid I have to scarf up.
Yep.